Alright, guys. So, as always, get out the regular, which actually, because I was talking with you guys for too long, I gotta get out my regular. So, everyone, throw up your graph papers, you're getting it out. Just flash it in front of the screen, let me know you got it. If you really want to lie to me, you could show me anything and then just not take notes. So, let's not do that. Let's start 2021 off with some honest, good math work. Alright, now, I actually kind of need help with remembering what we've done and what we haven't done, because I think we ended class on the last week before break doing some Desmos stuff. So, guys, if we start going and you're like, we already did this, like, tell me, please. That would be sweet. Before we dive into stuff, let's talk about announcements. Sorry, that was what is in purple up here, is me saying that. Khan Academy work is due the 12th. This is quarter 3 now. If you have quarter 2 work still outstanding, it's in map. I updated your guys' map yesterday. I updated all the chapter 1 and chapter 2 progressing to masteries this morning. So please go check map during extensions today. And if you have something in there that you think should be a different grade, let me know. When people email me to change Khan Academy grades, like change your grade for Khan Academy, but the grade that's in map, I get on those really quick, right? So over break, I wasn't super fast, so it was break. I kind of tried to ignore my email. But now you need to be mastered by Friday. I don't know why I didn't put this on here, but what this should also say in plan book is mastery deadline's Friday, right? Not that you're submitting it on Friday, because it might not be mastered. You need to submit it like as soon as possible, so you have time to work with the teacher if you need to. Please open up Schoology, if you do not have Schoology open yet, and find your way to our slides while I submit attendance real quick. I want you guys to be able to see our slides when we go into breakout rooms. And I think I have my Zoom set up so you guys can share your screen from the breakout room. Oh, you're so going to be faster than me because I closed my tab. So in our remote round 3 folder, if you have a progressing on chapter 1 or chapter 2, you need to do this. If you already have a mastery, you don't have to. Here's the weird thing. I've gotten a couple emails from people saying, like, well, there's this assignment in Schoology. Do I have to do it? No, do it if you want to. And if you want to make it go away, just go in there and submit it. You can even submit it blank, because if your grade is already a mastery, you don't have to do this. But if your grade's progressing, you have to complete these for chapter 1 and chapter 2 respectively. This is where I want you, is on our slides. Did we talk about the battery charge question back before break? And even if it looks easy, I'm trying to jog our memory slowly. But have we talked about this? Yeah, I was trying to remember where we stopped. I know we've talked about the slushy problems before, but did we talk about Sean's?
We finished off on Bugs Bunny and Mr. Moore and finding which altitude was higher, I think.
Yeah, see, I don't think we've made it to these questions.
I think we did. We did break up.
Here?
Yeah.
So we did get to those. All I could remember was Desmos, and my recording must not have worked, 'cause I didn't have a recording. So we stopped here.
Yeah, I think yeah.
Did we get past this one? Or, like, did we talk about it?
I think we started to talk about it, but I'm not sure if we finished. I think we finished.
So this is a perfect place to pick it back up. So let's break into our breakout rooms, chat about this real quick. It's okay if we already did it, and this is, like, kind of easy for you guys. I'm perfectly fine with that. Let's take a couple minutes to talk about what we know from these two situations. And I know you can't see a lot of the table for Bugs Bunny, but you can see enough of the table. So I know when this pops up, you can't, but over here in Schoology, remember that if you want to just keep it on the Schoology slide, you can do this and just click through the slides down here. You can see enough of the table to compare them. All right, let's do breakout rooms. Oh, that's not what I wanted. There we go. Bye-bye. Oh. Open. That would help. Bye, guys. If you have Schoology open, you shouldn't have to write all of this down before you leave. And I think... Oh. It's always fun when I'm talking and then I look up and I'm muted. Was that enough time or do you guys need more time? Alright, if that was enough time, I want you to throw in chat, privately to me if you remember to, please, who dug faster? If you want to justify why, go ahead and do that. But I want you to throw in chat. And if you need more time, I just need to know that. But who dug faster? How do we know? How can we compare this? All right, I'm going to open our rooms back up. A few people are saying that we need a little bit more time. I'm going to open your rooms back up and give you like maybe 30 seconds in the room and then the minute that it gives you to come back or whatever. So I'm not going to give you a ton of time, but I'll give you a couple minutes. Try to answer both questions. You guys have any issues you want help with? And what's funny is no one is ever going to watch this part of the video where I'm searching for my calculator. Nobody's probably going to watch this video in general because everyone's in class today. If I don't find my calculator, it doesn't matter because I can just ask you guys for the answers. Hey, Dewan, are you here? That's what I thought. Something weird is going on with Dewan's computer. Breakout room 4. Did Dewan ever join you guys? Ivan and Colin?
I got it.
You're on twice now. Here, I'm gonna kick off your other thing.
Okay.
That
happened before, like, it just keep like randomly kicking.
Yeah, turn your video feed off if you need to. Ivan, can you stop the light show? It's gonna like make somebody with unknown epilepsy have like a bad reaction, which can seriously happen, which would be very scary. Hopefully that was enough time at this point. What do we think about who dug faster? Throw it in the chat. If you did not previously, who dug faster? Can anyone volunteer? You can just use your real hand if you want. All right, Sebastian, I'm going to you then. Okay, and you put it in the chat to everyone. Now you gotta defend it and say why. So, Sevi, since you put it in the chat to everybody, tell us how you got your rate for Bugs Bunny.
Oh, I put it in the chat to everyone?
Yeah, you did.
Oh.
It's alright. Just tell us how.
Well, there's two ways that you could have done it. Well, you could have just divided the 1.6 by 2, or you could have subtracted the two different speeds from the two different.
No, wait. We can just divide the 1.6 by 2?
The negative 1.6 by 2, because he does that in 2 minutes.
Do we know that he starts at 0, though?
Not really?
Not really. So the dangerous thing about what you're saying is it might work, but it might not. So what you're saying is true. If this is a proportional relationship... Whoa. Okay. Don't do that. So, Kelly or whoever that was, if you are intentionally raising your hand and putting it down like 10 times, you're not going to get called on. I will guarantee you of that. Zoe, what would you like to say?
What I did is I found the difference between the 2 and the 9, which is 7. And then I found the difference between the negative 1.6 and the 7.2. Which was negative 5.6. So then I divided that by 7 and got 0.8. And then I multiplied that by 2 and figured out that he did start at 0. Because when I multiplied it by 2, it was negative 1.6.
Yeah. So, Sevi, what you said is right, but it won't always work because if this table is not a proportional table... Sorry, you guys cannot see... If the table they gave us is not a proportional table, that won't work. Like, the rate we got wouldn't be the rate for the entire table, so we always want to check the change in the one side versus the change in the other side, which is what Zoe said, was when she looked at the change in altitude, that was 5.6. The change in the time, that was 7. Now, whether you think about it as positive, negative, I don't really care. I wrote a negative here, but really, this is a positive change. So if we make that a positive change, it makes the rate negative. So our rate here is negative 0.8. Feet? Meters per minute. What's our rate up here for Mr. Mole? Shout it out. Just unmute and shout it out. Yeah, this negative 0.6. It's the thing multiplied by the independent variable. So remember, the rate for the situation is always multiplied by the independent variable. So then, since we figured out that Bugs' rate is 0.8 meters per minute, guys, you can always go to the bathroom. I'm never going to say no. Really, if you have to go, I'm never going to say no. So you don't have to chat it to me if you're going to the bathroom. Don't take us with you. Unless you turn your camera off, then I don't really care. But... no, that's a joke. Don't take your computer to the bathroom. That's a bad idea. All right, try this one for a moment. Do you guys want to just do it like here together, or you want to go into breakout room so you can talk a bit easier?
Break.
Let's do some quick breakout rooms so we can chat about it. So please have Schoology open or write down the important information before you leave, but it would be easier for you if you have Schoology open and can just follow along. Dewan, do you remember what breakout room you were in? 4? I'm putting you in breakout room 4. Maya, everything okay? Akshay, do you remember what room that you were in?
I wasn't going to, but then something happened and then
I got you. I'm putting you back in there. You guys don't have to rush back here. When I do the 1 minute thing, you can stay in your room until it brings you back on its own. Like, you're welcome to stay there.
We finished.
Oh, well, then there's that.
Yeah, this one is, in my opinion, a little bit easier than the last one. Because it gives you a lot of the information you need to write out the formula.
Well, Kelly, if you will calm it down on the hand raising, would you like to talk about this one?
Yes, I'm so sorry about that. Does it, like, pop up on your screen every time you do that?
It changes your position in the Zoom, and what's dumb is when you put your hand down, it puts you back to where you were. So when you do that, everybody's screens move, and it makes noise on my end. Because the only way to know what's going on between all my computers is if I have, like, audio notifications. So it literally goes bleep, bloop, bleep, bloop, bleep, bloop, bleep, bloop, bleep, bloop. It's not cool. Not cool.
Oh, okay, I'm sorry. I didn't know that it did that. I thought you had to go into the participants
No.
and then you
Now you know that, yeah, that on our end is like whoop, 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 whoop. It's a little crazy. Now, if I have chat open, every new chat doesn't, like, make a noise. But yeah, so Kelly, would you like to tell us how your group solved this problem and wrote out the function here?
So, we didn't really solve it as a group, actually, but the way I solved it was, you can see it gives you a really, like, it gives you something very nice. So you have $30 for each hour of work. So that's already half the formula, right? So then it says 4-hour job is $170. So that means the initial fee is going to be whatever 4 hours times $30 subtracted from 170 is. Because when you subtract that amount of money, you have the leftover money, which is your initial fee. So if you have $170, right, and you subtract 4 times 30, which is 120, you're left over with $50. So then we can write out the initial, or the function, as f equals 30t time, or plus 50.
So I'm kind of trying to convert what Kelly said to on my paper. Kelly, everything you said is great. What we have is nice because it tells us $30 an hour and a fee comes out to be $170, right? And then Kelly says, well, if it's 4 hours is what they give us, that's the $170. And then Kelly said, well, that is $120 plus whatever the fee is, which makes the $170, resulting in the fee must be how much? $50. So then when we go to write our function of what Jabari charges, that function for cost is the $50 fee, and you could write this in either order, plus 30 times, now they want us to use T. I don't love using T, but since they tell us to, I will. I'd rather use H because T looks like a plus sign. Now, why are we talking about this problem that is slightly easier? We want to talk about vocab. That's why we're really talking about this problem in this moment. A function. So please, on your paper, write down the word function. And if you want to start a new page, you could. One of the, like, most important rules around a function is that each input Actually, let me ask you this first. Would it be fair if today, when Jabari shows up and does 4 hours of painting, it's $170, and I'm like, all right, sweet, come back and do it tomorrow, and Jabari shows up again, does 4 hours of painting, and is like, all right, you owe me $500. I was like, but you told me the function of this as your price. That wouldn't be fair, right? If all of a sudden now the same amount of time was a different price. This is the rule that, like, all functions have to abide by. Of each input only has one capitalized, underlined, highlighted, whatever you want to say, output. each input can only have one output. What this rule is also called, anyone know? It's abbreviated VLT, and you've maybe seen it. I think in science you maybe talked about it. Nobody? It is the vertical line test. The vertical line test says if I draw a vertical line through my function, and guys, you've been doing this in your Khan Academy work. Sorry, my keyboard's falling over and I don't know where to put things. When it says evaluate the output of the function for an input of like x equals 4 or an input of like x equals 5, you're kind of doing the vertical line test, because if you went and found that input and had multiple outputs, your brain would be like, wait a minute, how this can't work. If x is 4 and y has 2 different values, like that wouldn't make sense, at least for a function. So, real quickly here, let's just stay all together in a group. Read this and figure out what the function would be here, and then we're going to talk a bit more formally about the next stuff we're going to do. Actually, here's what I want us to do, because I did put a few of these into our slides. There are 3 more of these. There's Colin painting figurines, there's a temperature of a chemical solution, and there's James playing an arcade game. You may have seen these in your Khan Academy work already, you maybe haven't, but doing these will help you when it comes to your Khan Academy stuff. I want to put you back in the breakout rooms and give you like 5 minutes to try to solve all 3 of these. So take like 4 minutes and then I'll pull you back. And you, guys, like I told a few of you, you don't have to come back when it says like 1 minute warning. You can wait till it brings you back all at the same time, because otherwise we just sit here and kind of awkwardly wait. So make sure somebody has this open, and you guys can screen share. I don't know if I said that or not, but I have my settings. You should be able to screen share in the breakout room. So go see if you can figure out the 3 functions for the next 3 problems. Dewan, I do not know what keeps happening with your computer, dude. All right, 10 more seconds and everyone should be back here. And here comes everyone. All right, let's go Ivan, because you got the crazy awesome light show going on. Did you guys come to a function for Colin painting his figurines?
We think so.
Walk me through what you guys did.
So, first we just figured out how much figurines he had. Like, he had 12 figurines. And then we read the bottom part. And we got confused for a little bit. But we were like,
the number of figurines left to paint is a function of the amount of time Colin spends painting. So we decided that we thought the answer was F equals 20T because he paints every figurine. It takes 20 minutes to paint him every figurine.
Close. So everything you said is right. It's just how we notate the function. Adam, you want to give it a shot?
I have a bit different of a function. It's F equals 12 minus T divided by 20.
So I agree with the 12, and I'm not saying I disagree with the second part. I'm just going to take this one part at a time. Let's make sure we all understand how we got to 12. The problem tells us he has 9 figurines left after 60 minutes of work. Since the problem also told us 20 minutes per figurine, this tells us, oh, there must have been 3 figurines painted in that time, meaning he had 12 total. So this is why Adam started his function by saying 12 minus. Colin starts with 12 figurines and is going to paint some. Now, the weird thing here is we look at our function and we say T is time in minutes, right? So we got to talk about what change happens compared to the amount of minutes that we do. So every 20-minute increment is a figurine, right? So I'm trying to break this down for people that I know don't understand how we get here. So what we're going to use is T over 20, because then when T is 20, this, what is in parentheses, actually becomes 1, right? When T is 40, this actually becomes 2. When T is 60, like 3 figurines have been painted in 60 minutes, so 12 minus 3 would give us the 9 that we would have left. So guys, this is one of those weird things where we say, how do we figure out what we have initially, and how do we talk about the change? We're going down, right? The amount of figurines we have left to paint is going down, and it goes down 1 every time we get 20 minutes. These new function problems are going to start to get a little complicated like that. Like, it's not just like, oh, $5 per hour, 5x, or whatever. So Adam, really good job here figuring out that we get to T over 20. And there are probably a few more ways that we could write this. One of which being 12 minus 1/20th T. We could also write it like that. Right, I don't know if we need to zoom in a little bit more. I can't actually zoom in. There we go. So if we wanted to, we could say 1/20th times T. That would also work, because that's the same as T over 20. Do we need more time for the chemical problem, or are we ready for that? Anybody want to volunteer to talk through it? This one? Or do we need more time? The temperature, our final temperature, big T. We often use big T for temperature. For the sake of time and how much I have left that I want to make sure we talk about, I'm probably going to keep us all together at this point. So they tell us it started at 21 degrees. He heats it at a constant rate, so we know it's going to be linear. That's what it telling us a constant rate tells us it's going to be linear. And it's 75 degrees after 12 minutes. Can anyone volunteer to tell me what to do with this information of 75 degrees after 12 minutes? Can I just do 75 divided by 12 or 12 divided by 75? Zoe?
You have to subtract the 21 first because it doesn't start at 0, it starts at 21.
Now I'm going to write something that I really don't like writing. Change in T over change in T. Except little t, big T, right? Zoe's telling me I need to subtract 21 to find the change in temperature. Oh, crap. I'm backwards. This should be big T over little t. I need to do change in temperature over change in time. So my change in temperature to go from 21 to 75 was... Nobody? Really? Thanks, guys. 54, I think? From 21 up to 75. And then how long did that take?
12.
12 minutes. So we're going to do that division, 54 divided by 12. That will give us our rate. And we know we started at 21 plus, well, what did we find our rate to be?
4.5.
4.5. .5. What's our other variable here?
X.
X, the heating time in minutes, right? So this is really like a lowercase t if we wanted to mix t's. But that is our time in minutes. Questions on this one was a bit easier. This one we just needed to find the rate and go from there. The first one was a tad bit harder. And then James at the arcade started with 20 tokens. After he played the game 3 times, he had 8 tokens left. So guys, anytime you approach these situations, you want to be asking yourself, how do I determine the rate here? And we're probably going to be talking about rate in the tokens on top because the function is a function of tokens. Right, so guys, here's the, well, not the last thing, but one of the really other critical things I wanted to talk about was our function is talking about tokens. So our rate is going to be tokens, if I could spell, tokens per something. It's going to be tokens on top. That's going to be like the primary thing we're talking about. So here it's going to be tokens per like plays, right? Like times he plays the game. So to calculate our rate, how many tokens is it per how many plays? Well, they tell us he plays 3 times, but how many tokens goes with playing it 3 times? Put it in the chat. Let's make sure we're awake. How many tokens does it take to play 3 times? Or give me the rate. Or you can tell me what the rate is. Yeah, what people are starting to say in the chat is if there's 8 tokens left and he started with 20, that means he used 12 tokens, which, yeah, the unit rates that are starting to come in means that our rate here that we care about is 4 tokens per play. So we could write this as we start at 20. We are adding on, but we're adding on a loss, right, of 4 tokens. But then they tell us G is our independent variable, the number of games we play. Now, you'll often see this being T equals negative 4G plus 20, which is a little bit nicer than saying plus a negative. But either way is right. Whether you put the rate first or whether you put the initial value first does not really make a difference. Now, here's the weird thing. When we start to talk about functions, when it's not even necessarily numbers. So read this question to yourself. Can the side dish be represented as a function of the main course? The side dish as a function of the main course. So that would mean that if we were to write this out, can the side dish be represented as the function of the main course? So what we would say is side dish is, right, or side dish equals, if we're writing out the function that is side dish, right, our result is side dish. So in any function, the result is dependent on some sort of input. Right, so when this asks us, can the side dish be talked about as a function of the main dish? So side dish is dependent on, well, is the side dish dependent on the main dish? Well, look at the, I don't know, what do you guys think?
It's not.
So, pasta primavera gets salad. Pasta primavera gets salad. But veggie burger also gets salad. Wait. Is that allowed? Fish gets rice. Fish gets rice. Burrito gets rice. So, here's where we're going to pick up next time. And I'm going to take us back to numbers for a second. If we had numbers, can the duration of the ride be represented as a function of the time Jaden got on the bus? We could compare our numbers, right? Does every input match up to only one output? And actually, more easily to look at, if we come back to here, I wanted to make us scratch our heads and then come back to an easier situation. Check this out. The table compares the initial amount of fuel Lee's car had and the total distance she traveled using that amount in several different occasions. 30 goes to 100. Down here, 30 goes to 100. I don't see 100 anywhere else over here except for when I have a 30 over here. 35 goes to 120. The next time I see 120, it also came from 35. I don't see any other 120s or 35s on here. 40 goes to 140. I don't have any other 40s or 140s on here. So every number on the left seems to be mapping to only one number on the right. And if I reuse the same number on the left or reuse the same number on the right, they have to be identical as they were before. This is one of those features of a function. Every input maps to one distinct output. So then this is where we're going to pick up on Thursday. What about when it's not numbers? What's our input, what's our output, and what is allowed to happen? So with that, we're pretty much out of time. When we start to look at it with graphs, oh, that just loops back around because I changed things in order. This, real quick, vertical line test, this passes because anytime I draw a vertical line, I only hit my function once, right? So linear functions are nice and easy to test because any vertical line is only going to hit your graph once. So everything we've been working with previously is a function. These are where we're going to get into, is this a function? Is this a function? And we will pick it up there on Thursday. In about 10 minutes, I'll be on Zoom for extensions. So if you need help, please come to extensions. I am happy to do more math. Aside from that, have a wonderful day. Get mastered. Email me if I need to change grades. Check map. I'll see you guys Thursday.
Bye.
Bye-bye. Thank you, guys.
Thank you.